All right, thank you. All right, so let's get started. It is our pleasure today to open up and start talking about the Hubble Advanced Products, and in particular, how you can discover them at MAST. So that will be our focus. MAST is the Mikulski Archive at Space Telescope. It is basically the particular place where both Clara and I work with. So probably one of the first opening questions you may have is, what is the Hubble Advanced Products, right? What is HAP, as I will sometimes refer to it in my slides? If you're familiar with the Hubble Legacy Archive at hla.stsci.edu, like you can see here, it's pretty much the successor of that. What HAP tries to do is automatically generate higher quality versions of imaging observations that have been taken that have been taking place with ACS and with C3. So it's very similar to the HLA, but it is the latest version of the calibrations and reference files, and it'll provide imaging mosaic products as well as source lists. And it is being run as part of like the HST, the Hubble Space Telescope pipeline. So in addition to getting your traditional raw files or your FLCs or things like that, you will also get these files, including if you have proprietary data. So if you have your own program that is in this exclusive access period, you can also benefit from having these higher quality products being produced for you automatically. Some of the key features of what HAP provides is mainly the improved astrometry, and it is active sort of imaging instruments, ACS and WIFC3 in particular. Some of the ways that we have improved the astrometry is by utilizing the new Gaia catalog, right? Gaia DR2. As part of that, we improved the GuideStar catalog, which is used for all of the guiding. So the initial astrometry, what we call the a priori astrometry, is already better thanks to the updates from Gaia. Now we also have something that we call the a posteriori astrometry. This is, okay, you have your imaging products, you've reduced them, you've drizzled them together, and now you can extract sources, for example, the ones you could see on the right, all of these lovely images of stars and galaxies, and then cross-match them with Gaia and refine the astrometric solution so that you have higher accuracy. Both of these solutions and any others are included in the download product, so you can always switch back between them if for some reason you are not satisfied with one or the other, or of course, given that this is science data, you can always recalculate it yourself. So HAP will be providing these what we call the single visit mosaic, so a single HST visit and the particular imaging products from that, as well as the source catalogs for that particular visit. Currently, the source catalogs are still being worked on, so what you can see online, once you go to, for example, the MAST portal, as I'll guide you through, you can only see the imaging mosaics for now. The source catalogs will be coming in a couple of months. And we will also be having multi-visit mosaics, which is where you take multiple visits of the same area of the sky and co-add them together to form much deeper observations. That's coming a little bit later. Before we jump into exactly how to search for this on MAST, I did want to spend a few minutes just going over what the hierarchy of our observations are, so you have an idea of what exactly is HAP and how it relates to the original HST data. So on this diagram, I have the HST, the original Hubble data in green, and the HAP in blue in various shades for various levels. So you may be familiar with the HST association. That is one of your high-level files that is comprised of multiple HST members that have been combined, co-added together to a final image. So this is pretty standard. This is what we've already been providing. HAP is this new thing. You can see that the file names or the observation names are much longer. They're more descriptive, or at least more human readable, right? This encodes a lot of information, but you have to sort of be aware of the nomenclature for HST, whereas for HAP, even an layman person will be able to see, oh yes, this is an HST observations. I can see the instrument is ACS, the filter is F14W, etc., etc. So these HAP exposures, there's 3 levels to HAP: exposure, filter, and total. The exposures are one-to-one to the members. So you can see that for each member, there is a HAP exposure, and all of the HAP exposures, they've been redrizzled, they have the improved astrometry, north up, east left, that sort of thing, and they have been combined together to form the filter observation, which is analogous to the HST association. So this is a combination of those improved images for that particular filter. The total observation, also known as the detection image or the white light image, is what happens when you take members from different filters, but for that same single visit. So in this particular scenario, there's actually like 2 other filters that have been observing that same area of the sky. The total observation combines them together. This is useful, for example, if you are just interested in finding sources regardless of what their fluxes are. For example, you may have dropouts at one band or another. The total image is very useful to extract sources in that fashion. And this linking is what drives some of the functionality that we will see in MAST, the ability to link between the original HST data and the new HAP products. So let's jump right into how you can search for Hubble Advanced Products with MAST, in particular with the MAST portal, mast.stsci.edu, and we will talk about AstroQuery a little bit towards the end as well. So if you go to mast.stsci.edu, one of the main sort of entry points is just the ability to perform an observation by object name or right ascension declination. This is your standard cone search. It is the most common way people use MAST. And you can see here, I've put in some coordinates and some search radius. I have some results. I have filtered them just to have HST data. You can see there's 10 rows. You can see the various different observation names, just like I had in the few slides before, right? The shorter HST names and the longer HAP names. But the key thing is that the provenance name is HAP for these products, whereas it is whatever calibration pipeline, so Cal ACS for these ones in particular. So this is one way you can distinguish your HAP from your HST products. The mission, though, is the same HST mission for both of them. Now, if you want to search just for HAP data, you don't particularly care about what region of the sky, you don't want the original HST data or anything like that. This fact that the provenance name is HAP can help you by clicking here on the advanced search. So when you click on advanced search, you get this panel here. This is our advanced search panel. By the way, before I go too long, I do want to point out that we do have an actual demo planned, a webinar for going through the MAST portal live. I'm only putting screenshots here in the interest of time, but I believe that's on Wednesday by Chinwe Edani. So tune into that if you actually want to see this live, or of course, stop by our booth. So on the advanced search panel, you can put a bunch of different filters on exactly what you want to search for. And if you put provenance is HAP, press enter, you can see that filter has been applied. And in this particular case, you can see 18,000 observations at the time that I took this screenshot. You can click search and you'll get back to the image here, except you'll only see the ones with provenance name of HAP, and you can filter them on the left-hand panel in any way you want. So that's the second way to search for HAP data. The third way is to rely on this linking mechanism that I presented before. This is by searching by observation ID. So when you have this drop down here, you can click it and select the ability to search MAST by observation ID. You can type your observation ID, and in this example, I put the HST association, but you could put the HST member name. You can put the HAP member name. You can put the HAP filter names. Any of those will work. You click search and you'll see, for example, for this particular scenario that I got 4 results. One of them is the HST association that I typed in, but I also see the HLA data. So this is that older data that has been built from the same files. And I also see 2 rows for the HAP products, the total and the filter image. So all 4 rows are returned because all 4 of them are using the same underlying data. Right now, I do want to caution that this is in a test version of our systems. This is not yet fully in production yet. So even though HAP data is flowing in, the ability to do this that I just described of putting the observation ID and getting the multiple results is not quite working yet. So you'll have to give it probably a few more months until we fix that and implement it. One other way to continue exploring this is, let's say you click that ... Let's say you're interested in the F814 HAP observations. You can click it, you can add to basket, and that gives you a panel like this. By default, minimum recommended products is checked on, which means you will only see those 3 science files associated to F814. This particular HAP filter observation. Now, I have disabled that so I can see all 68 files. I only selected 1 row, but the portal basket functionality now gives us all data that was related to it thanks to this linking structure. So you can see the HLA data, you can see the HAP filter, the HAP exposures, the HAP total, the HST association, and the members. And it's all because they're all tied together via this linking mechanism, right? So this data was the underlying data that produced this one, and all of these others are built from it. So in a bit of a summary, this is that linking mechanism, right? So you can put in your HST or HAP observation ID. You get rows that are all the different levels of that. And when you add to basket, you can drill down to it. You can see, for example, the members of the association or the members of the filters that all were used to construct that same observation. And so now I'll pass it along to Clara to talk about how AstroQuery can be used to search for HAP.
Right. Hello. So I'm going to talk about doing some of the things that David just showed you, but programmatically through a Python session. So AstroQuery is a Python package. It's an affiliated package of AstroPy that is specifically designed for interacting with web forms and archives. So MAST maintains a submodule that can be used to access our archives. So most of the things that you can do through our web interfaces, you can also do through AstroQuery. So the important import here is the one at the very top that says from astroquery.mast import observations. So that is where we're bringing in this ability to query the MAST archive through Python. The rest of the function of the imports are for manipulating coordinates and analysis. So I'm going to perform essentially the same search that David performed at the beginning. I've made a SCI coordinate object with the RA and dec in the same format that David used, which is our angle and degree. And instead of just doing the straight up cone search, which I could do, it would be observations.query region. But I've chosen to go into that advanced search that David showed you second. And in this case, I'm not going to just get all of the HAP data. I'm going to say that I want a cone search around this coordinate with a radius of 0.01 degrees, but I am going to specify that the project is HAP. Note that I could also have specified the provenance, so that would be provenance underscore name equals HAP. Both of those columns in the HAP case are the same. And so in this way, I get, instead of getting those entire 10 results that David got, David got when he filtered for a mission of HST. And so if we look at this table, the mission corresponds to this obs underscore collection column. And so these are all HST, but I've also specified that I only want the HAP one, so I'm only getting these 4. And this also includes all of the columns. I've just shown the ones that are most relevant to explaining this. And so again, I'm going to then drill down into the same product that David looked at, this F814W filter that I've pointed to with the giant red arrow. So next slide. So in this case, I then do a get product list query. And so that's the equivalent of putting things in your basket in the portal. And you can see I printed out the length, and that's the 68 products, which is the same as what David showed you when you unclicked the minimum recommended products. By default, AstroQuery does not filter in that way, so you get the entire 68. And what David was saying about the linking is evident here as well. Looking at the unique combinations of OBS collection, which is mission, and project name, we can see that we have both HLA, Hubble Legacy Archive, and HST, and we have those HAP results and that calibration ACS result. So even though we only put the HAP product into the basket, it went and found all of the other associated products to put in the basket. Next slide. And so then to show this a little bit more clearly, if we actually show, we're going to show all of the science type products with the mission HST. And now we are getting those, this just shows the top of it, but we get a whole selection of our HAP products, and at the top you can see those 3 minimum recommended products that would be the only products that show by default if you use the basket. And then you can see that there are also those associated HST products. So in this way, you can perform the same functionality using AstroQuery, which is particularly useful if, for example, you want to do this for a lot of different products. You figured out exactly what you want using the portal, and now you want to do it in a loop. It can be really easy to do that in AstroQuery. And then also at this point, both the portal and AstroQuery have the ability to choose which products you want to download and then download them to perform more science on them. And I'm going to pass it back to David for questions.
Yep,
yes,
that
thank you.
is what we had.
Okay.
I know it was a little bit fast. There's a lot to dig in through. I do just want to point out that we are, both of us and a bunch of others are at the STScI booth, so feel free to stop by at any time. You can always email us and tweet at us or go to the Slack channel as well, and we are happy to give you more details and demos of how this works out. But for now, if you have any questions, feel free to type them in the chat and we will do our best to answer them.
If anybody would like to unmute themselves, they're welcome to ask the question as well. So if there are no questions right now, I know that there are demonstrations going on in the Zoom room at the Space Telescope Science Institute's exhibit booth. They have a lot planned. If you go to the exhibit hall and the VFairs platform, you'll see daily activities down in the bottom corner. All of our exhibitors have activities. So David, I think you're going to be over there in the booth doing demos.
Yep.
Okay.
And we'll both be on AAS Slack as well.
Okay. But we can hang out a little bit longer if anybody has anything they want to ask.
I guess to reiterate, there is HAP data available right now. So if you go to mast.stsci.edu, you can find this. The only thing that was missing was the linking mechanism that we described that is still being worked on. It does exist for the HST, HLA links, and actually for some high-level science products. So we do have a presentation, another webinar later this week by Scott Fleming about high-level science products. And I think he will mention the Ulysses project, which I believe has used this linking mechanism as well.
Great. Okay, well, Clara, David, thank you very much.